So welcome everyone for cloud computing and big data. Also welcome to our online audience as well. Today the lecture is number 9. So we are a little bit more than half through the course essentially. And you have seen a lot of different concepts. Today we have another concept called platform as a service, which builds neatly on top of infrastructure as a service, what we had the last time. So let's look on the last time what we had and understood as infrastructure as a service, because they really build on each other. And you have here on the left side, essentially the illustration and also some nice graphics to support the understanding that the infrastructure is, of course, very much the bottom layer, always thinking about compute, storage technologies, but also networking. So interconnecting all these different, let's say, different elements in this. Of course, virtualization is orthogonal to this, not really shown here, but you know from previous lectures, virtualization is basically always applied. So when you talk about a CPU, rarely you have a real CPU, you have a virtualized version of a CPU and you connect them. Then what we will talk today is something which we put on top. So elements for software developers in the cloud. You need databases, you need queuing mechanisms, you need user identities, storages, but on a much more higher level than using the real, let's say, underlying hardware. And this will be the major concept of today, thinking about what would you do to put different Lego bricks together to create apps, right? For instance, like we have seen Angry Birds, but also Philips Hue with the lights. Then the highest level of this is software as a service, is really applications. So what basically are now the idea of using the clouds? What is the end user customer experience? Now, this word end user is, of course, now really, let's say, a bit difficult, because the end user on the infrastructure as a service level are administrators. The end users of the platform as a service are cloud developers, software developers, people that have to create apps, develop software. And of course, then on the application layer, the real end product, so to speak, the end users would be people that require these applications. But you see here that basically different market segments are accessed by different, let's say, levels of this. And we have also seen in one of the previous lectures, like last time, that people not only stick to infrastructure as a service, they use the different services in combination with each other. So nothing prevents you to use a couple of services from the platform as a service level, and then a couple of them from the infrastructure as a service level, and of course, combining this with software as a service. And in a way, this is all what cloud computing entails. Of course, you learned in one of the lectures, swiping the credit cards is always something which is alongside, no matter on which essentially layers you are right now. Of course, there's where the money comes in. And we will reveal this again today in the small written factors, what that means when you have some products that you want to use. Then the other part of the lecture was more, again, thinking about the idea of an infrastructure, what it really means and where does it end? And basically how you can take decisions of thinking, should I put an infrastructure in-house? We call that on-premise, essentially, in our house. Or should I put it just in the cloud? And always, basically, when someone comes to you in the company and you're kind of responsible for this as a cloud developer, you always have to take this decision and have to think about what are the benefits for the companies, right? And there's essentially this kind of 4 categories which have not a really strict boundary between each other, but of course, which means with lots of flexibility on the one hand of doing everything on premise in your own data center, you would have lots of flexibility. You can do what you want. The trouble is you have the bare metal at hand, right? That means you have to buy the service, you have to operate the service, maintain the service, and you have to directly know what load you have in the systems, right? So this is really hard sometimes for a startup to already know or to already scale up very quickly, right? We have some examples today. Of course, you have to scale suddenly with lots of many users that come overnight. And if you have everything on campus, you cannot just simply add servers overnight. In the cloud, of course, this is just at one finger snap. And then all the idea of, understanding MapReduce, really deploying the software. We had it in one of the lecture. It is also, of course, something to understand the replication strategies of a company, the MapReduce framework, how you basically host and operate it. You can do it very simply by downloading appliances from the web and do a kind of more virtualized setup, or you really make the move and say, I let a third-party provider do that for me, right? This is a common model where you just have basically MapReduce hosting, where you agree with someone, please do the IT for me. I think here at Vanya, Origo there in the segment where you can get a hosting from MapReduce. It's not yet the full experience of as a service like we know from Elastic MapReduce and Amazon, right? So this is really something where you don't have any specific contract. You go to Amazon, credit card, you get Elastic MapReduce. And then, of course, completely up and down with scalability and everything. But we have seen you have to pay the price for that. Then we looked a little bit also on the storages. We always were focusing on compute in the beginning, and also in the deep learning, more on the executing and so on. Then we looked also that there are different storage philosophies or storage approaches. Of course, some of them are much more mimicking a file system, and other are more like the object storage, where you just have key value pairs. And this is a kind of concept we will take up today in so-called NoSQL stores. But the idea is, of course, to pay different prices for that. And orthogonal, you have always the excess ratio. We had this in one of our earlier lectures. Memory is always fastest. I mean, the cache is always fastest than memory. And as soon as it comes to disk, it's getting slower. But of course, when you have really big, large data sets, putting maybe everything to disk is too expensive. If you talk about mega petabytes or the ones that we discussed with the SKA, where 20 minutes, 20 seconds, 1 petabyte. Then you quickly have the disk full. And for this, there's so-called glaciers in the cloud where you have tape archives, right? They can have a lot of capacity. There you can store petabytes of data. But of course, there we also saw that the downgrade on this, when we click on the MP3, like in Spotify or so, then we of course want to hear it immediately. When you do this on the tape archive, it takes actually quite long time to actually migrate to disks and then play. In other words, this glacier, these tape archives are not for real direct usage. This is something what you put, as the name suggests, deep in the glacier, and only if you need it, then you slowly migrate this. The migration of many small files of petabytes can take weeks, right? So for a company that might be very important to consider this. And you see with this, you cannot just save the cost because this storage is of course very cheap compared to the, let's say, byte ratio. But in other words, also, it's just for archiving and not for active usage. And all of these different concepts are in the cloud existing and basically used in different companies worldwide and have interesting concepts, but they're very rudimentary, right? So we don't look yet on one level up. And this is basically what we want to do today in the platform as a service character. So arguably, you could say some of the topics we strived with your storage, kind of thinking about the S3 object storage, right? Key value storage, where you just put things in. You're almost already at the platform kind of character, but it's still plain storage, plain data, and not much more added value, so to speak. And the idea of the platform as a service is to bring added value, and this for more or less a specific clientele. So it's basically for cloud developers. A very interesting model where people would not have to think about scaling your application anymore, depending on the amount of users you get, right? Some of you maybe take software engineering, you have to think about these things. Is your, let's say, app server engine built for 30 users, or is it built for 300,000 users? So this means a lot. Or is your data in a small SQL relational database a couple of megabytes of size, or do you have petabytes of a database? If you have a petabyte of a database, then the traditional one, the oracles and all of those existing doesn't work anymore. You have to distribute. So all of these are basically, let's say, tools for developers, which normal end users that just want to have the applications, Google Docs and Clicky Bunty, Spotify and things, of course, would never think of that. All underneath, there's lots of different Lego bricks you pull together to actually create the experience of Spotify, to create the experience of Angry Birds or Philips Hue. Of course, these has to be developed by people, by developers, and they need the certain tools. And I put you here some different pieces where I think there's lots of learning experience to know that. For instance, the NoSQL stores are incredibly important. If you go to, let's say, a job interview in this area, you have to know what NoSQL stores are, right? If you remain in this SQL area, then you basically have, let's say, relatively hard chances these days. They are incredibly often used. It stands for not only SQL, to really be provocative to SQL databases, and we will discuss the benefits of that. And this is also by far let's say, one of the key concepts used in the cloud. We will look at this. And then, of course, the whole idea of a development lifecycle with the Google App Engine. So think about more a development process in teams online in the cloud without any more doing, let's say, things on a local laptop, compiling and all of this. No matter which language, you basically can do this nicely in the cloud as well. As usual, you see GRE pricing models. So this goes alongside. Of course, this definitively means a lot of costs. On the other hand, you have inherent scaling, right? You never think about this. It just comes automatically with the components. Otherwise, if you're a software developer and do your little project here on the computer, it's a very hard time to scale up to 100,000 users, right? You need a backend platform for different servers to host the different user requests. So just programming, let's say, an app on your laptop and then, having success like Angry Birds would not really work. And this is a complete environment for this that you can use. I focus a bit on the Google platform. You can have similar things on others. On the advanced concept, in the second part, we have some success stories where I just show you the benefits where known, let's say, products like Philips or IKEA and Twitter and so on all use these different components for different purposes. Also here we see quite a mix, like Rovio Games uses essentially Google, but also Amazon. They migrate from each other every now and then. So basically here, just some insights, a bit in the learning and machine learning area, but also going beyond this with some more data or big data oriented topic as the course suggests. So an interesting lecture, more or less, as I said, for a clientele of software developers, but of course also very relevant in clouds today. Also, if you think about that, you maybe have to develop versions of different software and so forth. Already we discussed this. It's basically sitting happily in the middle, reusing, of course, lots of elements from the infrastructure as a service. So if you want elements from the platform as a service, of course, include considerations of the data centers, networking and servers and storage and computing devices, but adds a certain value now. And the certain value is really the whole development cycle of software, which entails not only operating systems. You want to have your system running on Windows, on Linux, on Unix. So you have different versions of the same software to provide to your users, and Mac, not forgetting this. But then there's a whole development lifecycle program, right, where you have to think about how that works. This is also something what the platform can give you. And usually these are very strong components. So you can say that many of the different languages are actually provided, not only Python, it's Java, C++, C#, all the popular ones, up to scripting languages like Ruby and things like that. And they usually have a certain nature of solving a problem of a developer. You see here one. So launching a certain application is a problem for a developer, not for a real end user, right? It will just see one click Angry Birds and play. But of course, for that, a whole level has been launched. There's a certain amount of randomness inside this game, blah, 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 etc. Then to monitor the users. So there's a monitoring infrastructure, public subscribe mechanisms to get notifications when the user's doing certain things. And then the big concept of billing. Think about this. You as a developer now want to start in some package in a Java program, some billing, right? And you want to implement this on your own. So you have to talk with Valita here in Iceland. See, you get a REST API and implement all of the billing infrastructure. You basically have their billing components where everything is already prepared for you, where you just enter the software, get the credit card from the customers and can have a billing service. Usually for developers, of course, now also very important because that's where the money comes in then for the game. But it's, of course, something also what you don't want to re-implement yourself. And of course, this all concept of having another add-on and another add-on if you swipe your credit card in the games, right? Often there are free games these days to hook you, as I said, also in the cloud. But then this enables you to top up, getting more levels, getting more power in this particular game, and so forth. So in a way, we see here a really tremendous help for developers. And when you look on the infrastructure, what they can use and build on, I mean, there's lots of different GPUs we know for different technologies that you see. We use them, for instance, in machine learning. So you just have the infrastructure underneath and need a certain component or platform to run and take use of this. We discussed this in lecture 6 and 7, how important that is, a GPU for deep learning. You don't want to do this without deep learning these days. Then we had the lecture 4 with virtualization. Almost everyone uses virtualization. It's for basically have an enhanced resource utilization. And the same goes with, essentially have this different VMs that you also can, as we said, migrate much easier and so forth. So powerful infrastructure. I just put that slide more or less because we discussed it so far only in AWS, right? If you remember, I always showed you slide in the Amazon Web Services. This is now the Google Cloud, essentially. So still you see a very similar nature of infrastructure we can now build on, even if it's just a Google Cloud. Now, thinking now further, what this entails, as I said, of course, infrastructure is always there, right? The cloud is not thinkable without infrastructure. There's always a real physical server behind. You just don't see that. The physical ones is usually abstracted with virtualization layers, as we discussed in one of our group. And this makes up the so-called infrastructure as a service level. And now the question is now how we leverage this for the platform as a service idea. And this is where this application developer comes in. Is it a web application? Is this an app application that you want to develop? It doesn't matter really. These days, there are also many of these applications on the web that also have to scale and so on. And you see they have very nice REST interfaces with HTTP requests where you then can, interface with the real devices on the users and basically perform your different games that you have, or Philips is for Lightning, and so on, home Lightning solutions. And the interesting thing is that inherent in all of these are big portfolios of Lego bricks, as I call it, right? As a developer in the cloud, you just don't think about the low-level problems anymore. You see, I need a Lego brick for billing. Okay, there's something in the Google Cloud ready for this. I need a Lego brick for actually managing my software development lifecycle. And this could be very difficult in the cloud. Not only you have these different devices like Android, right, and basically the iPhones and so forth, you maybe have different versions of the applications running. And you have to keep the older ones alive because people have built, let's say, the old Philips Lightning part, but the new Philips Lightning part comes out, and not basically you cannot just get rid of the old ones because your customers still use that for 5 years. So you keep the same software in parallel in different versions for the users active, right? And this whole development cycle with build, upgrades, maintenance, bug, and so on. This is something, of course, where the SDKs in these platform as a services are very strong in. They're dedicated for machine learning, they're dedicated for different other purposes, and help you there significantly. And in a way, that's how you really can see the platform as a service. See always it as Lego bricks, which are a bit more than just this plate in Lego, if you remember, right? Who has not known Lego before? Just a short, curious question, right? There's this one big plate, which is just gray, nothing on it. So this is the infrastructure as a service. Now the beauty comes with the platform as a service, and the real house is then the final application that you buy, but you need the different, let's say, Lego bricks. And of course, the beauty is now here again, you just pay for what you use in these Lego bricks. Again, if you now would build, buy services from another software company or so, this can be very, let's say, cumbersome going out of the contracts again. Here, you just stop using it. This one Lego brick is, let's say, too old for us. So let's use another Lego brick that fits nicer. Of course, here you have really just this pay as you go approach and can really cancel quickly instead of doing software maintenance contracts with a software development company, which is maybe in 5 years. So it's sometimes relatively hard to go out of this. And of course, underlying is this notion what we had always in the course, scalability, right? Scalability is what we're interested in because it's called big data, the course. That means big users, big customer data, and the scaling of your applications is really directly in these components usually. So you wouldn't think about that anymore. When you have a billing, let's say block as Lego brick, it scales for 1 user up to 100,000 users, right? And the scaling inherently is done by the cloud for you. Of course, you pay a certain fraction, as we will see in some of the slides later, but still the overall idea is that basically you don't really, as a developer, don't have to do this anymore. Otherwise, think about what that means in code, yeah? If user number is 1,000, then do this. If it's 500, then do this, and don't, you basically had to program it all yourself to, migrate between different server loads to get the users really satisfied. They don't want to wait. So, and all of this is, of course, something which is in the app engine from Google, if you look at it concretely, which is perhaps one for startups, a very often used one, which is really easy to use and has lots of different components. And when you then have here the benefits, I listed you a couple of benefits here from the business use cases. You see something like cut annual IT overhead by $500,000, right? This is an example. Or scales more than 30 terabytes without performance, right? So in its data size. And once you're dealing really with this data sizes in practice, you will understand what that means to scale up to 30 terabytes, right? So this is something, of course, which you don't just do overnight with your application. It really requires scaling in many different factors. Another one I found is really the customer experience. Now think about that, of course, the waiting time when they click on something is really dependent on the success, for instance, on the app, right? We have seen sometimes probably apps in the App Store or so that are really, really slow, very bad programmed. And on the other hand, this is something where then when you have a good, proper cloud engine behind it, you don't have to care about. Usually it should be going relatively quickly. And inherently, there are different components successfully used in this. And this is, again, this Lego brick character. So there's a Lego brick for Google using cloud with a typical SQL engine. There's a Google-like search that you maybe need as another Lego brick. Maybe you want to search within your own app for something, for customers, whatever. The load balancing, you say, okay, automatically I want to scale. I want to know, is my app really alive? Is my users really using it? Logging, etc., etc. Security is actually a very big piece in this. Think about that your app should be also, relatively usable, but on the other hand, also very safe. And you see here some of the known Barilla noodles and so on, and very many others. But this is, of course, something to think about. And there are different examples here from how you can deploy these different Lego bricks. Of course, the heart of it is the app engine that you would use always in the sense, but it has now in combination with all the other services that we will talk about a little bit, some storage and so on. But here's really where these added component values come, right? So you add a component for publish subscribe for notification of elements. When you have logging, you have monitoring. You can very quickly with BigQuery go, let's say, through data sets. We will look at this. So all of these components are basically there for you, and you pick them, as you see here, nicely together to form a specific web application. And here you see it's a web application with dynamic content, but also with a very strong logging processing infrastructure, right? Dynamic content means people maybe can also download something on your own portal that you create for your hobby, whatever it is. Or for pictures in Iceland that we discussed for the volcano. This is something what you easily can publish and do with the Google App Engine, and then automatically scalable, right? There's a new eruption. There's suddenly overnight 20,000 more users of your platform. You don't worry about this. You still sleep because the Google Cloud can handle it. And the different examples, different components, we will look through a little bit here. The Memcache, the Firebase Datastore, all of them have some interesting key, let's say, unique selling proposition to do this and to combine this. And of course, this shows you the character, hopefully, of this Lego, right? You really build it together with different entities. When you have a game, of course, you need the app on the one hand, but you need a very strong server on the back end. But what does it mean, right? And you now look in the server, you can build it with the app engine. You have a very Memcache oriented one. That's again, is, as the name suggests, already alluding to using as much as you can memory, and then caching requests from users, right? Which might be very common. And with this, you have the speed in, lightning fast. But it really depends what application you do, right? So of course, it's a very dynamic process and very many different options to use these. And I provide you not with all of them, of course. This might be probably 200 components of the Google Cloud, and it's not my job. Here, I just focus on some of them, which you basically probably will reuse in life several times, like the NoSQL stores, or not only SQL stores. Have you used maybe Cassandra or something like this before? Not yet. Yeah, I think, unfortunately, I always thought about a course on NoSQL. But yeah, in a way, I think it's not really taught at the university, unfortunately. So I do my, small added value here, perhaps, to really go into a very big world. right? Today, this is really, I think, compared to SQL, really a very important way how to deal with data in the online world and in the world where it's not so much, let's say, updates of data. If you have this old oracles and so on, there still exists. The relational databases, let's say with some customer data, which should be always the same for everyone. But here it's really about data which has not so much updates, which you just read, right? Like level data of games. You don't need maybe all this sequential consistency because it will never change. Only what you do is the random characters or random goodies in this app. And then that's all what you do. So there are different consistency models, which makes them so incredible fast. If you do a, let's say, SQL commit to the database, then you have many, many consistency checks, right? Which makes the database incredibly slow. Of course, you have the benefits of these indexes, which these databases keep, right? But still, the idea is here really to have something which is for reading very optimized. And if you think about how many companies work today, or Google, as an example, as a search engine, right? They just accumulate. And that's why they're so good in Google search, because they have a very accumulated number of these links, right? And Google search strings accumulated. Once it's there, you don't change this. You search for this, period, locked, right? And another accumulated data. If you have, on the other hand, really, some user data that maybe you want to change the address again and so on for this, and basically do this a lot, basically very often, then maybe these stores are not so good for you. But for things where you just accumulate data over time and not changing so often, this is beautiful. Another Lego brick, if you want, but this Lego brick is loaded because it could be in many colors, right? So they are very different NoSQL stores. And in previous lectures, we had always one complete lecture just on NoSQL stores. And here, alluding a little bit to this, we basically have lots of different user ways of basically using this. Here's the Google App Engine, for instance, that you can use as in one example of how this works. You have the cloud that basically knows the status of all your different lightnings. And of course, for Philips now, they want to do this with many different millions of users of transactions now, right? And of course, when you want to change the light now in your room, you don't want to wait a long time. So all of this is something where they use different parts here in this cloud data store. And of course, your situation in the room does not change so often, right? So basically you have a Google Cloud Platform, which usually is very responding, and with this also scaling to all the different users. If you add light in different rooms and so on, of course, you can always add this and so on. Just here, it's a big topic, and you can read the user story yourself. Just some things which are, of course, very important. You see that you get as the testimonials from them. Here, backend, because it scales instantly. So that's why, like Philips, big companies that have nothing to do with IT, right? That's the point now. Think about the developers from Philips have to do this with the apps, but their business is lights. They don't want to do IT, right? IT is just for them a way to go towards a better lightning experience. And here they can potter off everything, which is infrastructure, services, and so on, and can concentrate on the light experience by using just the infrastructure. This is there. On the other hand, you see Philips Hue is very popular. Is someone maybe having at home, some devices of this? Usually it's the case. So basically they are everywhere these days. And it's very convenient to change the type of light and so on. And it basically, of course, they experimented with many different products before. You see 10 times the scale of other similar products, and with 1/10 of the workforce, right? So of course you can do it the traditional way, do everything yourself, not using these components, but this means often a very much more money investment and time. Then maybe look to this NoSQL cloud data stores. They are, flexible solutions. You see a little bit here the combination of cloud data stores. There you would talk rather of kind and not really a table that you would have in the SQL world. You would talk about entities, and in a relational database, you have always this kind of traditional way of thinking about a row, and the row should be always the same with every different fields, right? And this is different. In an entity, it must not be the case. You have certain properties, and not all of them have the same fields, like in the relational database. I'll show you an example in a short second. Still, basically, both use the indexes, the keys, that you also perhaps hopefully know from the SQL world from databases. And there you combine again different parts, and you have for different purposes, different NoSQL stores. But here you see the main concept when you think about different users as an example. These are very good when, for instance, information about the users that we see today is not always the same, right? And this is a key consideration. You see here that these people always give different elements out from themselves. So some are actually happy giving the phone number, some not. Others rather prefer the email address instead of phone numbers. Others give the full name. Others just, have a very strange name. And if you see Facebook and your friends, you will notice this. Many friends are there as Nadine, or some people have the phone number, some have a full profile, some have actually one short item working there and there. The web nature of all of this is usually that users are extremely different from each other, right? So that means an SQL table with all the different fields would be just slowing down everything because people don't use all the fields usually. And for this, you have this kind of NoSQL stores very effectively. You just define a kind of key structure, and then the values are basically your bin structure, and it's very incredible performance. And this is, of course, not a concept of the Google Cloud. It's just examples I show you here with Google Bigtable. You find the same ones, again, also in the Amazon infrastructure. So Bigtable is really something when you have petabytes of data, when you have this 30 terabytes of data to really scale over different services, because otherwise, when you don't use this in the cloud or in a kind of distributed computing setup, you can't really work with petabytes of data. Here it's also nice that you can deploy this on the HDFS, on the Hadoop distributed file system, as we discussed in lecture 5. So with this comes a replication strategy, the migration strategy in terms of fault tolerance, right? So to access just another part of the database somewhere else, and the whole layout format, and it was basically one of the really success of Google in the early days. And why? Because it was, of course, very useful for web indexing and so forth. And with this, just an example, when you want to really scale with now petabytes of machine learning, to digest this, you have this Dataproc service that we know was the one with MapReduce, right, in lecture 5, with all the different open source tools, Hadoop, Spark. And you combine this with Cloud Bigtable on HDFS, then you're basically ready for, let's say, an SQL-based table in the one hand that really can scale to petabytes. And you combine just these different layers. This data lab and RE platform are specific ones for machine learning and for data mining, for data analysis. And if you combine those, you essentially have a really scalable machine learning platform that for finance or so whatever customer comes is really ready for, let's say, petabytes of data. And you see even with time series processing data flow, this is, let's say, as a stock market or stock broker analysis company, something you really need because it changes literally every minute in this and can make a big difference. Some things of that, how it is used, you already know from the idea basically that we had in one of our previous lectures. You want to have pointers, not basically showing you to someone else. Also, you want to have the big impact ones. And these are very nicely indexed also with the key value structure when you switch essentially the kind of round of the different websites to understand who is pointing to whom, right? So this is one way of really make it completely, let's say, high performance. Maybe summarizing this a bit. So NoSQL store should be, in my opinion, really a whole lecture, essentially in other courses like databases and so on that we don't have here right now. But it's very important to take away message that they are really for unstructured data. People don't give away all the same information. It's really very easy to deploy Cassandra and all of these that are around there. They have no schemas, right? Not SQL schemas that you know from the relational table world. And this is basically very well normally in this SQL world. You have always these tables created by schema, consistency checked, is the name really filled and so on. And here you would say rather in this world, you have low data consistency requirements, but you're ultra fast. And that's how you can serve an app. You don't want to do an SQL query with an app. And I will talk a little bit more about this when we think about also graph databases, which have some off in this area. There are some different categorizations you can have in these. And you see on the right-hand side, of course, immediately there's not only Cassandra, Mongo, and so on, the popular ones. There are many different ones that enter in this field. And we will talk about this essentially also when we combine it with graph databases. Apache HBase is another good example how you can, for instance, implement now the search engine that we had on the other side, which is essentially from a physical perspective looking like a relational database table. But from the conceptual view, you see directly the idea, many empty fields, so to speak, but they never stored, right? And that's the interesting thing. In the NoSQL store, it just stores what you really give it. And if you have the normal relational database, and the conceptual view would be the right view. But essentially here, we don't do this in these stores, just to give the differences to this. And you can implement them nicely with this kind of key value pair character. Here's a JSON notation. So you don't have a schema where everything is the same. Here you would have different objects, and you just identify several of the features which we would call in relational databases maybe fields. But here you have just, let's say, similar properties you want to have, but not really for every object the same information. This is just an example from a MongoDB. It's also extremely popular. The MongoDB is often used. Cassandra is very often used for different purposes. And with this, I mean, this is not so exam relevant to know all the differences of all the different, that's why there are no yellow blocks, but keep away that, NoSQL stores are important when you want to develop software professionally today in the web. Good. Maybe at the end, a 1-minute video as a summary, just shortly before we break. Just as a summary for the App Engine.
Give me 1 minute and I'll show you how App Engine can help you ship your next great app idea. App Engine is a fully managed serverless application platform with simple administration. Write your code in any of the supported languages, or run custom containers with the language and framework of your choice. When your code is ready, run gcloud app deploy. App Engine handles the work of uploading your code and running it on Google Cloud. It seamlessly scales from 0 to millions of requests as your app becomes popular, and you only pay for what you use. You can easily host different versions of your app and split traffic between them for A/B testing and incremental feature rollouts. You can debug and monitor your app, even in production. And for the security of your app, App Engine offers free managed SSL certificates on your custom domain. App Engine works as a great backend for mobile apps, APIs, websites, and more. So next time you've got a cool app you want to ship quickly, take a minute to look at App Engine. To learn more, check out cloud.google.com/appengine.
Okay, the usual disclaimer, I'm not paid by Google, but it was a good summary, I think, of all the coding you have to do with it. We break here for 10 minutes.